Hi everyone. No video today for me. I don't have my video camera today, so just the facts today. I'll be focusing on just the screen. So there is a worksheet that goes along with this. Make sure that you fill in the blanks afterwards. I will not be slowing down for the slides, so you should go back to the original slideshow and finish your notes from there. But listen to the lesson so that you get the main ideas from this. So, to begin with, what's the difference between climate and weather? Um, Sometimes people mix the two up. I've heard politicians say, take a look outside, it's snowing in March. Obviously, climate change can't be happening. No, that's the weather. That's a 1 day occurrence. If you take a look at the last 150 years for that day in March, and you find that, over the last 10 years, that day has been getting warmer and warmer and warmer, that's looking at climate. Whereas just looking at a one off, oh my goodness, it's hot outside today and it's the middle of January. That's just weather. So the key thing is we're looking at the difference between. Well, first of all, we measure the weather by taking air temperature, air pressure, cloud cover, cloud types, precipitation, and what we typically do is we measure those conditions day in, day out, year after year. And we've got really good records from places in Europe and Asia that have collected these numbers for centuries. Canada, not so much. A lot of farmers took weather records for the government for about the last 150 years, but that's about as far back as we have of really good records here in Canada. But there's other ways that we can get that climate information if we want to extend further back. But I won't get into that. So, whoops. If I can just go back, weather is the day-to-day conditions of the atmosphere, whereas climate is the long-term conditions. So what we want to do is measure the weather every day, and then take a look at 50 years worth of that day and get what the trend is. Well, on average, that day is typically between -5 and -2, and it tends to be dry at that time of the year. So we are going to be examining climate. Day-to-day stuff isn't overly important. We're looking more at climate and why certain parts of the country have one type of climate, whereas other parts of the country have a very different climate. So first of all, we have to remember that unlike, for instance, Belgium or the Netherlands, um, we're a huge country, and so we should expect some great diversity in the climatic conditions across such a large part of the planet. Not only are we a large country by distance, but by elevation, we have incredible differences in elevation. We've got parts of the country that are thousands of feet above sea level, and we have major portions of the country that are all around sea level. So, elevation differences will make a significant difference. We have areas that are far from a large body of water. Think of Saskatchewan. And then we've got other parts of the country that are completely surrounded by water, like Prince Edward Island. And then finally, we're in a part of the world that you may not realize this, but because of being in the temperate part of the planet, we have very variable weather conditions because we sort of have this ongoing battle between the cold air of the polar Arctic fighting with the warm tropical air coming up from the tropic zone. So that gives us, a lot of stormy weather, and so unlike some places where that have sort of the same weather day in day out all year round. So what are the factors that affect climate? So we've got this nice little acronym, LORN, or a mnemonic, I should say, that helps us remember the different factors. So L for latitude, O for ocean currents, wind and air masses, E for elevation, R for relief, and N for nearness to water. So to begin with, we know that when you go up to the far north, we get this Arctic climate or polar climate, or down at the South Pole, to, whereas we know at the equator it's much, much warmer. So, what leads to that? Well, first of all, if you take a look at the angle that the sun's rays hit, think of a flashlight shining directly on the wall. And you'll notice that the rays are very concentrated. You take that same flashlight and you shine it on an angle, you have the same amount of power coming out of the flashlight, but it's spread over a larger area, and so it's not quite as bright. And that's what's happening with our tilted planet. At the equator, they're getting the concentrated solar rays over a smaller area, and it's going through less of the atmosphere. Whereas towards the poles, not only is it being spread out over a large area, but there's more atmosphere that the sun's rays have to go through and more options for it to bounce around and not make it down to the surface. So this is why we naturally expect um, to be much warmer near the equator and cooler towards the poles. Be careful, don't just simply say north, because in Australia, if you head north, it gets warmer. So the southern hemisphere is different than the northern. Now, ocean currents. We know that we see pictures of British Columbia in the middle of January, people running around with t-shirts and what's called jogging shorts, and we're suffering through a negative 20 deep freeze here in the central part of the country. Well, that comes down to there's a warm ocean current bringing with it this huge body of water that's going to warm up the air along the coast of BC. So we find the mildest conditions in BC because of that warm ocean current. Whereas, unfortunately for Newfoundland, they've got all this cold water trickling down from the Canadian Arctic, and that brings with it a lot of cool, dry air, and so Newfoundland tends to be a much cooler place, even though it's at the same latitude as Vancouver. It tends to be a lot colder. And then we've got this interesting condition off the Grand Banks, which is a shallow area off Newfoundland, where the cold water meets up with this warm water from the Gulf Stream and creates a lot of fog. All right, wind and air masses. So I'm just going to, well, first of all, I'll go back to what's creating our major wind sources. So when we heat up the air, it's going to rise up because lighter air is less dense. So this is why a hot air balloon will rise when you start heating up that balloon. And then if you let the hot air balloon just sort of not be heated for a while, it's going to cool off and descend back down towards the equator. So in general, we have this system where warm air is rising by the equator and is coming back down near our tropics. And on a smaller scale, we're seeing that, for instance, the Niagara Peninsula. We have the heating of the peninsula on a hot summer day. You'll see all these clouds forming as the air mass comes over the peninsula. It gets heated up, goes way up into the atmosphere, and cools to make clouds, and we get those late afternoon thunderstorms for the during the summer. Now, the other thing that we have to think about is where that air is spending most of its time. So, for instance, we've had some pretty warm, moist days in the fall, and what's happened is warm, moist air from the Gulf of Mexico has come up into our area, brought with it those warm temperatures and the humid conditions. Whereas in the middle of winter, we might experience a deep freeze where suddenly cold air comes down from the Arctic. And because it's been over land, which doesn't have a lot of moisture, and it's extremely cold, cold air doesn't hold much moisture in it, it's going to make our conditions a bright sunny day, but extremely cold. So when it comes to air masses, the four main conditions are: is it forming over water or land, which will make a difference in whether it's whether it's wet or dry. And then finally, whether it's polar air or tropical air, which will be the difference in cold versus warm. So that's summarized in this section right here. All right, so elevation. The higher we go up, the cooler the temperatures become. And the average rate that the air cools at is about 6 degrees for every kilometer that we go up in elevation. So this is a neat little tool that allows you to get a profile. Um, so if you just click on the pen tool, click here, and then double click by Calgary, it's going to draw the shape of the land going from BC to Calgary. And what you're going to notice is there's an incredible elevation difference as we go through the Western Cordillera. And of course, that's going to create, along the coast, sure, it might be nice and warm because of that warm ocean current. But as you go inland and you go up in elevation, it might be the middle of summer, but when you're at 8,000 feet here, it's going to be very, very cool. So the valley down here might be, wearing shorts and running around with a t-shirt, but you go a short distance and you're up on the top of a mountain and you've got your winter parka on. Notice how high Calgary is. Calgary is interesting because you think of it being in a very flat area. Yes, it's flat, but this whole plateau area of Canada is at a very high elevation. So even though Calgary is flat, its temperatures tend to be cool because of the high elevation that they're starting off at. All right, try to get through this quickly. Relief, best shown with this picture here. So we've got lots of evaporation occurring over the ocean, and that air starts being pushed inland. And as it's forced to rise up, we know that as you go up in elevation, it's going to cool off. And cool air can't hold all that moisture. So the clouds start to form, and we get lots and lots of rainfall on this side of the mountain range. Whereas as soon as we go inland a little ways, it's going to get a lot drier. So going back to my elevation profile here. Oh, I hope you can see this. I think you may not be seeing this. When you go from BC into the interior plains is really dry. Alberta, Saskatchewan, Manitoba, because all the moisture has been dropped off on the side where the Pacific Ocean is. And so we always hear about Vancouver being a really rainy place, whereas Saskatchewan is pretty dry. All right, the last thing is nearness to water. We know that Lake Ontario takes a long time to heat up in the spring, so we get a little bit cooler temperatures in the spring. But in the fall, we luck out because that body of water takes a long time to cool down. So we get a little bit longer of a growing season in the fall, which is key for our grapes. This is made. This effect is 10 times bigger when you have something as big as an ocean. So this is why Vancouver doesn't get too many freezing conditions because they're right beside that warm ocean. It's not frozen, and as a result, it's going to keep the landmass a little bit milder during the winter. Whereas in summer, that ocean is not heating up as much as the landmass, and so it's going to keep the temperatures a little bit cooler during the summer. So what we find in areas that are maritime is that we don't get that hot, we don't get that cold, sort of the Goldilocks sort of situation. Whereas in a place that's inland, a place like, for instance, Saskatoon, Saskatchewan, you would expect to see the land heat up a lot during the summer, get really, really hot, but then during the winter, get really, really cold because the land heats up quickly and cools off quickly, whereas the ocean does not. I'm not going to get into this. All right, so you're not going to complete the chart on 155. Instead, what you're going to do is do 3 climate graphs and answer the questions that are posted.